Welcome back to Nick's Algebraics. Today I'm going to talk about sequences. So with me today, I have Random Guy.
I'm back. I didn't have anything prepared to say, so here I am.
We got Giorgio.
Everybody.
We have some new guests, Kara.
Hi.
And we have Devin.
Hey.
And last but not least, we have Jordan.
Hello.
So let's start off with what is a sequence? Can anyone tell me what a sequence is?
Yeah, it's a list of numbers in a specific order.
Very good. Yeah, so a sequence is a list of numbers written in a specific order.
Can I give you an example of a sequence?
Yeah, give me an example.
A1, A2, A3, A4.
Yeah, this is an example of a sequence kind of in general. And a sequence can be finite. It can have a couple terms, or it can be infinite. So this example right here, it's an infinite sequence because of these three dots. So every single sequence we're going to analyze in this lesson is going to be an infinite sequence. Notice how the first term is A1. So the index of the sequence, that's the subscript, is called the index. It starts at 1 for this example. But the index can start from 0 if I wanted to. I could have made the first term A0 and the second term A1 and the third term A2. That's also valid. So when you have a sequence, it would be great to have a general formula for the nth term of the sequence as a function of n. So this is called the explicit formula. So we're going to look at that in the first example. But basically, it's a rule that describes the nth term of a sequence as a function of n. So we basically want to create this formula here. I want to plug in a number for n, and I want to get the output. If I plug in 5, I want to get A5 from that. Okay, so let's do the first example. So write an explicit formula for the sequence below and graph the sequence. Assume that the pattern for the first few terms continues. So we have this infinite sequence here, and I'm going to label each term of the sequence. So the first term I'm going to call A1. So we know A1 is 1. A2 is negative 1/2. A3 is 1/3. And A4 is negative 1/4. And this goes on forever.
You notice a couple patterns right off the bat, don't you?
Yes. Again, we're trying to write an explicit formula for this sequence. So I need to find a formula for A sub n as a function of n. So we need to figure out what is this function. So let's ignore the alternating signs. Pretend everything's positive. If the sequence is 1, 1/2, 1/3, 1/4, what would be, in general, the formula for the nth term? If the first term is 1, second term is 1/2, third term is 1/3, fourth term is 1/4, what would be the nth term?
1 over n.
Exactly, good. So we know we're going to have a 1 over n in here. But we need something that's going to make the even terms negative. So to do that, I'm going to slap on a negative 1, but I have to raise it to some power so that the odd terms are positive and the even terms are negative. So does anyone know what the exponent of this negative 1 would be? So the even terms are negative. We're going to raise this to the power of n minus 1, right? Because if I plug in 1, I'm going to get negative 1 to the power of 1 minus 1, which is negative 1 to the 0. And negative 1 to the 0 is positive 1, right? Anything to the power of 0 is 1. And then you have times 1 over 1, which is 1. So you basically have 1 times 1. So when you plug in 1, you get the first term, which is 1. When I plug in 2, notice how you have negative 1 to the power of 1. So that's negative. And then you plug in the 2 here, so you get negative 1/2 for the second term. So notice how I put this n minus 1 because when I plug in an odd number, this exponent becomes even. And negative 1 to the power of an even number is positive. So I get positive numbers for the odd terms.
What if you make it n plus 1?
That's a good point. You can also make this n plus 1. That's also totally valid. because if I plug in an odd number, it becomes even and I get positive values for the odd terms. And if I plug in even numbers, this exponent becomes odd and I get negative numbers for the even terms. So you can do n plus 1, you can do n minus 1. It's exactly the same thing, but I'm going to stick with n minus 1. Okay, so that's our explicit formula. So this sequence has a special name. It's called the alternating harmonic sequence. The second part of the problem is graphing the sequence.
Can I just say, I don't remember ever graphing a sequence.
Okay, interesting. They need to emphasize that a little more.
I've lived this long without it. Just going to point that out.
Okay. So basically, we're going to plot a sub n versus n. When n is 1, we have a1 equals 1. So I'm going to plot the point 1, comma 1. When n is 2, we have a2 is negative 1/2. So we have 2, comma, negative 1/2 right here. What's going to be the point at n equals 3?
1/3.
Yeah, 3, comma 1/3. So right about here. And we have 4, comma negative 1/4. So that's right here. At n equals 5, what's going to be the fifth term? What's a5? It's 1/5, which is 0.2. So right here. So notice how it's alternating between positive and negative values. So my question to you guys is, why am I not connecting these points? Why am I just plotting discrete points? Why am I not doing this?
If you look at the sequence, it's just a bunch of numbers separated by commas. There's nothing like in between them, right?
Mm-hmm.
It's like it's not a continuous function.
So basically, there's no 1.5th term. There's no 2.7th term. There's only first term, second term, third term, fourth term, fifth term. So if I connect these points, it's kind of misleading. You're making it look like I can plug in any number between 1 and 5, like any real number, but I can't, because you plug in 1, you're getting the first term, you plug in 2, you get the second term, and so on. A lot of people say this is not a continuous function, but it's not continuous on all real numbers from 1 to infinity, but it is continuous on its domain. That's what we say.
There's always a technicality, huh?
Yeah. Sequences are discrete functions. So the graph consists of isolated points. So it's not continuous on the real numbers, but it's continuous on its domain. So that brings us to the next question. In general, what is the domain and range of a sequence? So a sequence is a function, right? This is a function right here. It passes the vertical line test. So what is that domain and range? Let's start with the domain. I have all these sets handy for us right here. So we have the set of all natural numbers. So that's 1, 2, 3, 4, and so on. We have the set of all whole numbers. So that's basically the same as the natural numbers, but it includes 0. We have the set of all integers. So that's basically all the whole numbers and their opposites. And we have the set of all real numbers. So every single number on the real number line from negative infinity to infinity, that's a real number. So for the domain, what do you guys think the domain of a sequence would be in general?
General or this?
Well, okay, let's start with this specific sequence that we have right here. What's the domain of this sequence?
Like,
Yeah, good, because you can only input 1, 2, 3, 4, 5, and so on. So for this specific sequence, we start the index at 1. So the domain is all natural numbers. But in general, it doesn't have to be all natural numbers, because I could have started this sequence at 0. I could have said A0 is 1, A1 is negative 1/2, A2 is 1/3. I could have done it like that. So I could have started this sequence at n equals 0. I could have started this sequence at n equals negative 10 if I wanted to. I could have made the first term, I could have called it a negative 10, and the second term could have been a negative 9.
do that.
I've never seen anyone start the index of a sequence at a negative number, but you could do that. So
So is the answer just, is it like all the numbers? Is it arc? Because it's just arbitrary?
not R because you can't start it at a fraction. I can't say the halved term. I can't say the 1.7 term. So back to the original question. What would the domain of a sequence be in general? It's going to be a subset of the integers. This is the symbol for subset. So it's a subset of Z, but typically, like Giorgio said, why would you start the index of a sequence at a negative number? So you're right, that's not very common. So typically, the index starts at 0 or 1. So typically, the domain is N or W. Okay, next up is range. In general, what's the range of a sequence? You can look at this specific example. What's the range?
1 to negative 1/2.
Well, it's not outputting every single number between 1 and negative 1/2 because it's not outputting 0.75.
So you have to be like super specific with like it would just be like 1 and then like 0.33 and
Well, the problem is like there's infinitely many points because this is going on to infinity. So I can't like list every single number it outputs. But
Well, why don't we just make it like -1 to the n minus 1 times 1 over n for all natural numbers n?
yeah, you can say that. But in general, that's for this specific example. In general, using these sets right here, what's going to be the range of a sequence? What possible things can we output? Can we output negative numbers?
We already have.
Yeah, we can output negative numbers. We can output fractions. We can,
You want us to say it's a subset of R?
it's a proper subset of all real numbers because it's not going to output every single real number. It's going to have strictly less elements than all real numbers. Do you guys remember the symbol for proper subset?
Get rid of the bar.
Exactly. So it's just this. You can definitely have a sequence that outputs imaginary numbers, but we're not going to deal with that.